The presentation for the Leaving Planet Earth, Rachel Parr and Catherine Browning. So we're going to jump right into our presentation, and we're going to start with the 7-step process. So for the first step, it is clearly define the problem. And in this step, as a group, we identified as a group what task, the problem that we want to know was what task would our function be doing, what inputs and outputs did we need to put in, or what other validation would be needed in order to have a successfully running function. So we reviewed the end user stories that we had created and decided to focus on the function calculate the fuel needed. That's a test matrix that I have pulled up on the screen right now. We then discussed the purpose of the function, the parameters and variables that would be needed, and other validations that would be necessary. In step 2, which is create the matrix, we defined a test matrix that contained all the possible test cases that would help our function to run correctly. We wanted to know through this test matrix right here what our function would and wouldn't do when given specific input. And we included the 3 test types that you can see. We have the valid, the invalid, and the boundary. For step 3, we developed the algorithm, and that is down here. It's this right here. And for develop the algorithm, we created the algorithm for the function. We started with the function signature. We used if statements as a way of checking for validity from the input. If an invalid number was entered, then the test case would fail for specific reasons, depending on the number entered. If a valid number was input, then the function would run within the specified parameters. And then for step number 4, we are to test the algorithm. So once we had created the test matrix, which is this chart up here, we then tested the algorithm with the table matrix we had created. We input different values for each column, staying within the specified parameters. We had valid, invalid, and boundary results, and the test cases were successfully completed. So as you can see, we filled in different numbers, making sure that in the valid section, it was a valid response, in the invalid section, it was invalid, and so forth. And then for the next step, step 5, that was translating the algorithm to code. So just give me a second while I pull that up. And it is, just give me a second. Okay, can you see it?
Yes.
Okay. So this is the creating the algorithm to code. So the algorithm is just words, and we actually needed to take those words and create them into code. And so in this step, we had to translate the algorithm to code by using the example of the block function and the reading. So by using that example, we actually filled in our code, and we had to make the changes for we couldn't keep the if statements capital. They had to be lowercase. After we had to use semicolons, we had to take out the then word and use the curly brackets instead, because we needed our code to be readable. If we had left in those other words, then it wouldn't have been able to have been read. For step 6, we had to create the unit test for the functions. So we needed to make sure that our function was going to run correctly and that there would be no errors. So we created a JUnit test program to test our function. We opened the test class and assigned the input and output variables and filled in the other necessary information. We then ran the test. We used all the same information that we used from our matrix case, and then all the tests were successful, so then we were able to commit it and put it in GitHub where we could share it. The next part I'm going to talk about is the code that I wrote in if statement. So let me pull that up on the screen really quickly, so you guys will be able to see it. Okay, can you see it?
Yes.
Okay. So an if statement, this is the code that I wrote for we needed to calculate the distance traveled by the player, and the best way to do this was by using if statements. So an if statement is used when there is only one action that needs to be accomplished. So in my example, I need the player to travel over 0 steps. The player can't travel under 0 steps. So that's my one action that I need accomplished. And if the conditions evaluate to true, so if the person enters in 2 steps, it evaluates to true, therefore the player can move 2 steps. If the player enters an invalid number, like -10, then it's going to return a -1, and it's not going to be able to complete the loop until the player puts in the appropriate number. The same goes for the pace of the player. The player has to enter in the correct amounts, otherwise the if statement will not execute properly. So this is a great way to control input and to make sure that the program runs according to how it needs to go. And the last thing that I'm going to talk about is, let me just make sure this pulls up on my screen. Okay, can you see that?
Yes.
Okay. So the last thing that I need to talk about was we each did different test matrices. Together as a team, we did calculate the fuel needed, and then the individual assignment that I had to do was that I had to calculate the distance that the player would travel. Our players had to travel across the desert, and they had to build a rocket ship. So we want to be able to, part of the game, we want to be able to limit their steps as part of the gameplay. And so each of these is the tests that I completed to make sure that my function would run correctly. So there's test case number 1, number 2, and then I went all the way down to the 7th test case, kind of like how we did. I made a matrix table for this. And then down here, as you can see, that all the tests passed 100%. So then I know that my function is working correctly. If anything had failed somewhere, then I would know which part to go back to, and then I could have sorted it out. And that is my part of the presentation, and now I will hand it over.
All right, thank you. Let me see if I can get to pull onto me and share my screen. Okay, so my first function, first of all, you can see my screen?
Yeah.
Okay, so the first function I'm going to discuss is I am going to discuss the game menu that I created this week. It is a good example of an if statement as well as a switch case. So obviously we have our menu here and with all of our different menu options. When the menu is displayed, then it allows for the player to input their selection. So here we're getting their input and they're choosing their option. Here it's trimming down the option they put in, making sure there's no spaces. And we have our if statement here stating that if their input is less than 1, they're going to get an error back. The error is going to state invalid entry must not be blank. Now if the entry is greater than 1, then it continues on to the next function. So the next function is whether it actually has to be one of the valid menu options. So we've listed the menu options up here. Each letter corresponds with their menu option. If they want to view the map, here's V, C for construct shelter, and so on. And this function, the do action, once they've made their selection and it's a valid selection, then the switch case will based off the selection they've made, will run that next function. So if they select V, then it will view map. If they don't select V, it'll continue on until it goes to the function they've selected. And in this case, maybe they select P, so it takes them to the function pack ship, which is down farther on, and we have pack ship here. So it would take them down the next function, and it would perform whatever is in that function. So there's nothing in this function that's up right now, but say they picked move person, they picked M for move person, it now takes them down to here, and it will iterate the function that is in here. It will call this function from the move person view. Now the next function that I would discuss would be under my control functions, which was inventory control. Again, we run the test matrix like Rachel had discussed with calculate the fuel needed. We ran the same test matrix on mine, and I actually had calculate rations. So in my function, my two attributes would have been the number of people and then the inventory item, so the food item. And in this case, we would be looking at it as another if statement. If the number of people is less than 0, we're going to have an error. And if the inventory item was less than 1 or greater than 100, we'd have an error. Other than that, we would, if they were both within the parameter set, then we would take the inventory item divided by the number of people, and that would give us our return of rations for the function in the control. So the next section that I'll talk about will be about the scope and lifespans of variables. So this is also a good example of that, in the fact that we've declared our variables, number of people, and inventory item. We've declared them here in the beginning of the function. Now, within the function, we use them again, and we're referencing here. So these variables are only being used within this specific function for inventory item and number of people. It's referencing what we've declared here in the beginning, only within this function. Anything declared outside this function is used for another function entirely and won't be using these same numbers. It's only using what's been previously declared. And the next function that we're talking about is pass by reference versus pass by value. So a pass by, let's say like a pass by value is when they actually would enter something in. So if we have our inventory control test here, they passed by value, they've entered in number of people 6, inventory item 2. So they directly passed these items, versus if we were passing by value, and here I showed you this move person. So we're not directly inputting a number or a letter into here. Instead, this function is calling another function, this move person view, that's been created here as another class. It's calling this other class instead of calling whatever has been inputted, a specific number or letter. I believe this is everything that we needed to cover for the functions and for the presentation. Hopefully we've covered everything we need to. And thank you for watching.